So the workstation build is complete, and if you haven't been following along, go back and check parts 1 and 2 for some of the build, philosophy, and design choices I made. I'll talk a little bit more about that in this one, but let's go ahead and show some of the build. So if you haven't caught up and want to know what's in this build, just real quick, it's an i9-7940X. I've got it overclocked to 4.6 gigahertz at 1.2 with an offset of minus 40 millivolts. It's got a 2080 Ti that I did the power mod in a previous video, and 32 gigabytes of Trident Z RAM, running at 3400 megatransfers per second at C16. So it's moderately fast, pretty decent for this and quad channel setup. The loop is running distilled water with benzalkonium chloride as a biocide. This particular one's PT Nuke PHN, and that's what I like to use. It's the clear one. The blue one is not really copper safe. You'll get some ions in there, and eventually if you have a leak or something, it could cause issues. But I've had distilled water leak in systems before and not short anything out. It kind of crashed and the image froze because it was a CPU block dripping right onto the GPU. That's an issue, but it survived and I'm still using it, so no issues there. I know that the pastel fluids are pretty popular right now, but I like just plain old distilled water and it hasn't let me down. Performance is pretty good. I prefer to just use colored tubes with the build design and how the aesthetics work out. As far as loop design goes, so I'm using a DDC pump. I think this one's actually a Barrow pump off of AliExpress. And that goes into the back of the video card. So you can see here, out of the pump, into the back of the video card. And there's a tube back here coming in through the inlet of the back. And it's plugged in the front, goes through the video card and out this other side of the video card right into the CPU. Those two parts were a little bit tricky because trying to fit this back here, the way this vertical mount is set up, you have to attach the GPU to the vertical mount first in this Lee & Lee case because there's no space to get to the screws to mount the GPU back here because it's recessed. So you have to mount the whole GPU onto the PCB, the little daughter board that's in here for the vertical mount, have the extender connected to the GPU, and then put it in place. And kind of while it's in place, before you actually fasten it, I had to run this tube over here to connect to the pump and then connect the PCI extender. So it was a little bit of a hassle to get worked out, but I think it looks pretty clean having the tube coming in from behind. The other option would have been to have it run in front and then have this one come out, but I like this a little better because now you can only see these two tubes up here. And the second one coming out of the CPU is actually running behind the motherboard tray, and it runs back behind here into the first radiator, which is this one. And both of these are in a push configuration. So this Lee & Lee 011 Dynamic has a whole lot of holes in it. I'm not too worried about airflow getting in. It would technically be a negative pressure kind of setup, but this is full of holes. There's a gap here under the PCI riser. So it's not an issue to have no inlets on this, and a negative pressure setup is not too bad. The reason why I went with this is because these two components will generate quite a bit of heat, and I've had systems run hotter than they should have based on the amount of radiators that were in them, just because the hot air coming through one radiator as an inlet was coming through the second as the outlet. So that hot air could heat up the second radiator, which the water flows through and heats up the first radiator. So it kind of accelerates that process and you end up losing the effectiveness of the radiators. So in that situation, you may be better off just using one radiator, is what I found. This setup I think will work well for this case, and I did a couple load tests with it open like this, no issue. I'll put the side panels on and update that in a future video. So out of one radiator, and we'll take a closer look at this in some B-roll, but out of the first radiator, I come into the second radiator through that and had to do some funny business with the 45s and a 90 to get it to go right. I had some kinking issues in the hose. That's just the nature of using soft tubing and trying to have little bends like that. A couple things I did find with soft tubing is if you have a piece of soft tubing and you want it to attach to something and kind of have a little more motivation to go in a certain direction, you can heat it up a little bit, and you find that most soft tubing has a curve just because it's been stored, usually looped. So most of it will be curved. You can heat it up and straighten that out, and that'll make straight runs with soft tubing look almost as good as hard tubing. You can use those little silicone inserts too that's used with hard tubing to help you straighten it out. And if you do that, you can also heat it up and bend it to a position that you like. And you can usually get a little bit tighter bends if you do that than just bending it yourself, because soft tubing will kink depending on the radius of the bend. So that's something you could do if you've got a heat gun or a hair dryer or whatever the case is. The stuff melts pretty low temperature, so just be careful with that. But that is something that you could do, and I actually did that here going into the CPU because it wasn't perfectly straight. There's about a 2mm drop, and I had the GPU mount as low as it could go. So for that one, I had to actually warm up the tube and then offset it just a little bit on the two ends, and we'll show that in some B-roll as well. Like most projects, there's always holdups, and I ended up having to change the way I design the loop compared to how I initially imagined it going. Before, I was going to do parallel from the CPU to the GPU and then back into the GPU, kind of using the GPU header as a distro block, a little mini block that will split up the water through the GPU and into the CPU. I've done that in another build, and performance is just as good. The one thing that I realized is the water moves fast enough through this kind of loop that it's not going to heat up sequentially. So if the parts are in series, it's going to work the same as if they're in parallel. And the water just moves fast enough through it. What really matters is the temperature of the water in the loop as a whole. And really the only thing that matters is how much you can cool down the water compared to the ambient temperature. So that's what I found. And parallel or serial, it doesn't make a large difference as long as you're getting to all of the components at some point and the water flow is high enough. Now you can see performance increase from having a little bit better fluid flow rate inside, and even that is pretty minimal. At this pump at max, with both of these on load, the CPU temperatures would vary between about 3 to 5 degrees variance from minimum pump speed to maximum pump speed. In my opinion, it's worth taking the 3 to 5 degrees hit at max load for having a completely silent DDC pump, because they're not that silent when they're at max speed. But they also run at like 4,000 RPMs max speed. So that's my opinion. I set it just a constant, about 2,000 RPM. It's pretty silent, and I don't have any issues with that. But I did end up having to order some extra fittings, and that's why it took a little longer. Had to order those from AliExpress, so I had all the same fittings in the build. For this one, I was using 9.5 ID by 12.7 millimeter OD. So that's basically 3/8 by 1/2. You may see that commonly referred to as 1013, but on AliExpress they identify it as 9.5 by 12.7, and I measured it, and it's between 9.5 and 10, and between 12.7 and 13. So, you know, it's within the tolerance of what they'll send you, but if you see 1013 as the fittings, those will work for this type of tube. Just for whatever reason on AliExpress, they don't use the nominal size. So what that means is that the tubing is only 1.5 millimeters thick, and that may seem rather thin. I don't mind. Some people like the look of the thicker tubes. If you're using maybe the 1016 tubes, you need to have different fittings. I had some 1013 stuff already, so I just used 1013 in this build as well, and I don't have any issue with that. Most stuff is all going to be G-quarter sockets in the CPU, the blocks, the radiators. So that's not a big issue. There are different size sockets. There's, 3/8 as well, but G-quarters, what you'll find most stuff. I think all of the EK stuff is G 1/4. One other thing about these fittings is they're pretty tight. And if you get these Bixby fittings, they're pretty hard to actually fasten just because of how tight they fit onto the tubes. Now that's a good thing because it'll reduce the chance that they're going to leak. But it's also a bad thing because it makes them really, really hard to tighten. You have to really cinch down on them to get them to tighten. And what will happen is while you're tightening the collar, I'll have an example here. And here's one of them. While you're tightening this collar onto the fitting, it's really tight on the tube. So as you're tightening it, it'll screw into the G-quarter socket really hard. So when you go to take it off, when you go to loosen it, it'll unscrew it out of the socket. Sometimes that happens. Sometimes you'll be able to take the collar off and then this thing's super tight in the socket because you had to tighten it. But it does have a hex head inside, so you can get your Allen key out and just untighten it that way. I do recommend on acrylic blocks to be careful with that because you can crack the acrylic if you tighten it too much. This heat killer one, it's like a Delrin or acetal, so it's not as likely to crack. It's a little softer and less brittle than acrylic. but it can still crack if you like really, tighten these things down, but I haven't seen one crack myself. I have seen several acrylic blocks crack though. So that's unfortunate, and it happened with these kind of fittings because when you tighten them, it tightens them way more than you intend on, and really they only need to be finger tight. Once you get all your fittings set up, having a good plan is also a good idea. So when planning this build, I basically took a picture of it with the radiators in place, where I think I would want them, and the components in place. If you take a picture of it, you could just go to your computer and then kind of just draw the lines of where you want the tubing runs to go. And that'll give you a good idea of kind of scale and perspective of how much tube you'll need to use. If you are smart about it and you put a ruler in your picture along the bottom, it'll give you something to also scale your images by, so you could get an approximate estimate on how much tubing to buy. I bought 3 meters. I only ended up using about 2 feet in this one, so I've got plenty of tubing left, and I only used about maybe 3 feet at the most with some of the bits that I cut off. But that's really the hardest part, is just kind of guessing at how much to buy and how many fittings to buy. When you are building your loop too, don't forget to factor in the extra fittings, and it takes a bunch of fittings to do a couple T's and have a drain in it. So I have a drain on the bottom of this loop that comes right out, and I just kind of stuck it in the bottom here. I didn't have a male-to-male or a male-to-female coupler, so I just put another 90 and put a stopper at the end of that one, and that'll work as the valve for draining the loop. All right, sorry about that. We're back. I'll try to match up the color temperature, but the battery died and I had to swap it out, and I saw a setting that I wanted to change. So if it doesn't look quite the same, that's okay. I'll try to fix it as best I can in post. So that's pretty much the build. I think a drain's real important, and you should really flush the loop every 6 months or so to minimize growth inside of there, and hopefully that will keep the loop looking clear and nice, and hopefully keep good performance. And that's really the key there. The only thing I haven't done so far is install the power supply into the back. If you're familiar with the Leo 11 dynamic, it does have dual PSU slots, and I'll use the other slot for maybe some hard drives or cable routing, basically. I'm using a 1600 watt power supply. It's an EVGA Supernova T2. Definitely 100% unnecessary for this kind of build. Kind of the back of the napkin calculation will say that you need about a 750, 850 watt power supply to run this kind of build with 7940X and the 2080 Ti. I would go with 1000 watt or so if you wanted some extra headroom to overclock. And since I have power modded this GPU, it can pull about 350 to 400 watts. And if you're pulling more than 200 or so, about 250 to 300, that'll easily start getting close to that 750 mark. So that'd be about the minimum. I would shoot for a 1000 watt power supply, just because you got the pump, the 6 fans, all that other stuff running on there too. 1600 watt, that's unnecessary. It's just what I had. I don't have an extra power supply to throw on there in the 1000 watt range. So that's what I'll use for now until I can get another power supply, change it out, or until I need this power supply for my test bench to do some dry ice or something like that. So that's it for this content. If you like this kind of stuff, you know what to do. If you do want to see more or have any suggestions about future videos, feel free to post those down in the comments below, and we'll see you next time.